Hello, my name is Rob Dusenberry. I'm the Technical Applications Director here at CAD-CAM Consulting Services. CAD-CAM Consulting Services video series, where we will be sharing helpful tips and tricks for all of the products we have to offer. In this video, we're going to cover Chamfer Drill, the Chamfer Drill toolpath. We're going to use a spot drill, and we're going to drop that spot drill deep enough to maintain the different chamfers that I have here. Also, in this video, I'm going to show you a couple of switches that will set you apart from the average programmer. And our goal here is to make you the best programmer out there. So let's show you how to do it. I'm going to jump into the toolpath, and I'm going to select Chamfer Drill. Now, I'm going to use some of my selection tools here, and I'm just going to hold down the Control and Shift key together, and I'm going to double click on that feature, and you'll see that it grabs that whole hole there. I'm going to do the same here. Okay. And then let's just do a little bit of sorting. I'm going to sort it zigzag. And we'll come in here to the tool, and we'll take a look at the tool. Now notice this tool has a feed rate of 30 inches per minute with a spindle speed of 1500. Now, let's look at the tool. That calculation is really being calculated off to the largest diameter. But think about what we're doing here. We're not working off this diameter. We're working off of a smaller diameter here for the smaller chamfer and a larger diameter here for the larger chamfer. So at this smaller diameter, I want a faster spindle speed. I don't want this spindle speed. This is the diameter I'm calculating at. And same goes for the other diameter of the chamfer. That's the spindle speed I want to maintain. So let's just take a look at the cut pattern parameters. So in the cut parameters, simple settings here. Since my chamfers are already drawn, I'm just going to leave that at 0, and it will recognize the size of the chamfers modeled in. But here's the magic switch. Maintain the surface footage. So adjust the spindle speed based on the diameter of engagement, not the diameter of the tool. And we can also do the same with the feed rate. Two little switches there will make a huge adjustment. Now let's just take a look again. Remember, we have a feed rate of 30 and a spindle speed of 1500. So let's just go into the linking. I'm just going to change this to a 1/2 inch. I don't need it to go that high. And I'm going to hit the check mark. So let's kind of zoom in on these, and you can see that's the diameter. It drops right in there. Same with this one. On the larger hole, it recognizes that diameter chamfer and so forth. Okay, so now let's just analyze the toolpath. And let's look at this. And as you can see, that feed rate on that hole is no longer 30 inches per minute, it's 39.5. And the spindle speed's almost up to 2000. This one, feed rate is way up to 93, and that spindle speed is way up to 4,687. So it's adjusting the spindle speed properly for the diameter that we're cutting, not the diameter of the tool. And those are adjustments that a really good programmer would be doing, but could you imagine having to do that with a whole bunch of different size holes and with two little switches that have been there? All you got to do is turn them on, and right there, you're going to be the better programmer. So the proof is in the pudding. Let's take a look at the code. We'll take a look at our spindle speed for the smaller hole with the feed rate, and then the spindle speed and feed rate for the spindle speed and feed rate for the larger hole. And there you have it. And I hope this video helps, and I hope it's just one step closer to being the best programmer out there.